Hi, my name is Austin Lutz. I'm an automotive instructor at Dunwoody College of Technology, and today we're going to be learning about ignition systems and a basic overview of them. So there's two sides to every ignition system, both the primary and the secondary side. The primary includes all the components that conduct battery voltage, which is approximately 12 volt when idle and 14.4 when running. Some of the examples of the components include the ignition switch, which is what you're actually turning when you turn the key on your vehicle. This routes power to the ignition system. The ignition module, which is going to control the switching of the system, both on and off. And then also the ignition coil. The secondary side includes all of the components that deliver the high voltage spark to the system. Some of the examples on this side of the system are going to include the spark plug, which actually ignites the air-fuel mixture. The ignition cables, which may or may not be on every type of system, depends on the system, but it is the idea that it routes the spark from the coil to the spark plug. Distributor cap and rotor, if applicable, and the ignition coil again. Notice that I said the ignition coil twice. The important thing that you need to understand is that the ignition coil is the split point between the two systems, between the primary and the secondary side. What happens inside of the ignition coil is a process called mutual induction. You should remember this topic from back in 172 when we discussed alternators. This is the process of changing low voltage, approximately 12 volts, into high voltage, 40,000 or higher. What's necessary to ignite an air-fuel mixture is probably only 9 to 10,000 volts, depending on the requirements of the system, including temperature of the combustion chamber, the air-fuel ratio, things of that nature. So that can go anywhere from 9 to 10, but definitely the coil can produce well over 40,000 volts. The process of mutual induction, you need 3 factors or items needed. This should be a review once again, but we're going to recover them again. The first is we need a magnetic field. This happens on the primary side of the ignition coil. We need a conductor, which is the secondary side of the ignition coil. And then we need movement, which in this case is the collapsing of the magnetic field. So the process of induction takes all these parts that we talked about previously, the ignition switch, the ignition module on the primary side, battery positive voltage feeding to the secondary side, and then to the spark plug. We're going to produce 40,000 plus volts only using the original 12 volts from the vehicle's ignition system. On the primary side, what happens is that current flows through the primary side, then a magnetic field builds in the ignition coil. When the ignition module opens the primary circuit, the field collapses. Basically, the ignition module is just a simple switch that opens and closes the primary circuit. This would be an example of the wiring schematic from this. So we have battery voltage at the top side. The ignition switch closes anytime the car is running when we are cranking or the ignition switch is in the run position. Current flows through the ignition primary coil when the ignition module allows that to happen. A magnetic field builds, creates a strong magnetic field. Then once the coil becomes saturated or full of magnetic potential, the ignition module opens the primary circuit when instructed to. There's a larger process that goes through to have this happen, but as a basic overview, that's all that happens. We're going to explore why that process happens later. But as this happens, a high voltage spark is induced in the secondary when the field collapses. Okay? The secondary coil then receives the induced voltage, and that induced voltage is that 40,000 volts that we talked about. This follows a path to ground through or by jumping across the spark plug gap that's included within the spark plug itself. That gap can range from anywhere from 30 thousandths of an inch up to 60 thousandths of an inch, and when worn out, can be even more. Thank you for watching this basic overview of ignition systems. If you'd like to continue learning, the next video would be analog and digital signals.